In this video, we will use place value understanding to decompose to smaller units, using the standard subtraction algorithm and tape diagrams. In the subtraction problem 4,259 minus 2,171, I'm trying to figure out what the extra part is. I can represent this in a tape diagram. 4,259 is my whole, made up of two parts. One part, 2,171, and then an unknown part. For this purpose, we'll use the letter A to represent our unknown, or our variable. To begin, let's go ahead and put our total, or our whole number, in a place value chart. I have 4 units in the thousands place, 2 in the hundreds, 5 in the tens, and 9 in the ones. Now before I subtract, I need to make sure that I have everything in the right place. I'm going to subtract 1 ones away from 9 ones. To make sure that I can do that, I have to make sure that I have enough ones to subtract. 9 is greater than 1, so I have enough in this place value. When I look at my tens place value, I know that I'm subtracting 7 tens away from 5 tens, and I don't have enough tens to be able to subtract 7, so I need to borrow from the next higher place value. I'm going to borrow from the hundreds. I'm going to borrow 100. 100, when it's ungrouped, becomes 10 tens. When I look at my subtraction problem, the standard algorithm problem, I cross out one of my hundreds, so 2 hundreds becomes 100s. The 10 tens that I'm borrowing from that hundreds place value now gets added to the original 5 tens I have. Now I have 15 tens. 15 is greater than 7, so I know that I can subtract that 7, so the tens place value is now ready for me to use. When I look at the hundreds place, I can subtract 1 away from 1, so the hundreds is ready. And I can subtract 2 thousands from 4 thousands, there's enough here, so I know these remaining 2 place values are ready as well. Now I'm ready to subtract. In the ones place value, I am taking 1 of my units away, and I have 8 remaining. I'm going to reference this up here in my standard algorithm problem. For the tens place, I'm taking 7 units away, or 7 tens away, and I have 8 tens remaining. I will reference that in my standard algorithm. I'm taking the 1 remaining hundreds unit I have left, because 1 minus 1. Now I don't have any hundreds left. Reference that in my standard algorithm. And then the thousands, I'm taking 2 away from the thousands. I now have 2 thousands. 2,088 is my answer. I'm going to reference it up here by my tape diagram. A equals 2,088. These two parts together make my whole. But I want to check that by using an addition problem, just to make sure. 8 plus 1 equals 9. 8 tens plus 7 tens equals 15 tens. Of course, referencing the actual 10 there. So 1 and 5 is the 15. 100 plus 100 equals 200s. 2,000 plus 2,000 equals 4,000. Now when a problem asks you to use a picture or a place value chart, this is how you're going to do it. If the problem does not ask you to reference a picture or a place value chart, then you can just use the standard algorithm. But now that we understand how it works and why it works because of the place values, we'll be able to answer this problem with a much more ease.